A split air conditioner consists of two main parts, an indoor unit and an outdoor unit, which work together to cool your room using a refrigeration cycle. Let me walk you through how the system operates step by step. Inside your room, the indoor unit is mounted on the wall. When you turn on the AC and set a temperature on the thermostat PB sends a signal to start the cooling process. The first thing that happens is the indoor fan starts spinning. This fan pulls warm air from your room into the unit. The air first passes through the air filter, which traps dust, dirt, and other particles to keep the air clean. There are usually 2 air filters in the indoor unit to ensure proper filtration. After filtration, the warm room air flows over the evaporator coil. This coil is filled with a very cold, low-pressure liquid refrigerant. As the warm air passes over the cold coil, the refrigerant inside absorbs the heat from the air. This process cools the air down significantly. At the same time, the refrigerant absorbs so much heat that it changes from a cold liquid into a low-pressure gas. The now cool, filtered air is pushed back into your room through the louver. The louver helps direct the airflow, and you can usually adjust its angle to control where the cool air goes. During this cooling process, moisture from the warm room air condenses on the cold evaporator coil, just like water droplets form on a cold glass. This water drips down into the drain pan located at the bottom of the indoor unit. From there, it flows out of your home through the drain hose, which is why you often see water dripping from the outdoor pipe. Now, the low-pressure refrigerant gas that absorbed all the heat needs to get rid of that heat. It travels from the indoor unit to the outdoor unit through a copper pipe called the suction line. This line is insulated to keep the gas cold on its journey. Once the gas reaches the outdoor unit, it enters the compressor. The compressor is the heart of the AC system. Its job is to squeeze this low-pressure gas, which turns it into a high-pressure, very hot gas. Compressing the gas raises its temperature dramatically. This hot, high-pressure gas then flows into the condenser coil. The condenser coil is a network of copper tubes with aluminum fins, designed to release heat quickly. The outdoor unit's fan spins to pull outside air through the condenser coil. As the cooler outdoor air passes over the hot coil, it absorbs the heat from the refrigerant. This causes the refrigerant to cool down and condense back into a high-pressure liquid, though it is still warm. The fan then blows this absorbed heat into the outside air. That is why the air coming out of the outdoor unit feels hot. The warm, high-pressure liquid refrigerant now needs to be cooled down and depressurized before it can absorb heat again. It flows through another copper pipe called the high-pressure liquid line back toward the indoor unit. Just before entering the indoor unit, it passes through the expansion valve. This valve is a tiny but critical component. It creates a restriction, causing a sudden drop in pressure and temperature. As the refrigerant sprays through the expansion valve, it becomes a cold, low-pressure liquid mixture again, ready to absorb more heat. This cold liquid enters the evaporator coil inside the indoor unit, and the entire cycle repeats. The indoor fan keeps pulling warm room air, the refrigerant keeps absorbing heat, the compressor keeps pressurizing the gas, and the outdoor fan keeps dumping heat outside. This continuous cycle is controlled by the thermostat PBs. Once the room reaches your set temperature, the thermostat tells the system to slow down or temporarily shut off the compressor to save energy. When the room warms up again, the cycle restarts. The outdoor unit also has its own PBs to control the compressor and fan motor, ensuring everything runs safely and efficiently. The louvers in the outdoor unit help protect the condenser coil and direct hot air away. Both units work in sync to remove heat from inside your room and release it outdoors, which is the fundamental principle of air conditioning. This is why a split AC is so effective. It separates the noisy, heat-releasing components outside while keeping the quiet, air-cooling components inside with you.